then we'll move forward. Okay?
We did translation, move or extend the shape, reflection, numbers are different, rotation, turn the shape, original shape, and rotated shape, and delish, delay, dilation,
Dilation, yes.
yeah, dilation, shrinking, enlarging, um, we, yeah, rotation, reflection, change in shape, orientation, position, coordination, plane, origin, negatives, and yes, that's what we did.
Okay. So I'm going to now share with you the link of the concept board, and you just have to just come there, and then I'm going to share my screen as well.
Yeah, I'm on the board.
Okay. So previously what we discussed, I think today the date is 29th Jan 26. So what we did was, obviously we were doing transformation and its types. And we also learned about, in transformation, what was the coordinate plane.
The y-axis, negative y-axis, axis, those things.
Good. So we did the types of axes as well, the negative and the positive one. And I also told you that there are four quadrants. We also learned about the quadrants which are present. And for congruency, we did the types of congruency there on the PDF which we had. So on that, we practice congruency, so that is clear to us. Now, if we have to implement how the angles, the triangles, and the sides of the triangles are congruent or are matched to the other triangles. So I'm going to share my screen with you. Jennifer, are you tired?
No.
Okay. Okay, so please tell me, is my screen visible to you?
Yeah.
Okay. So basically, previously, what we did was we started and the conversations with transformation and congruences, and we discussed that how the angles and sides and triangles can be congruent, which are the types of congruencies and the types of transformations. And now we're going to obviously do certain examples and test with that, that how is this possible. So you have this task for 2 minutes. You have, I think this is a triangle, there are two triangles, and you have to tell me that if the triangles in the part A and the triangles in the part B, are they congruent or not?
Okay. A and B is, I mean, the both are congruent.
Okay, so both are congruent. So if you have to explain and if you have to write it down that the congruency, how would you write that?
Okay, I forgot.
Think about it.
I don't know.
Okay, let me tell you this. So I think we practiced this, but look at this. If you're saying that this triangle is congruent to this triangle, if we are saying that, so obviously you will write triangle ABC is congruent to triangle DEF. You just have to write like this.
Oh,
Okay, and for this one, just write triangle RST is congruent to triangle WXY. Okay, got it?
yeah.
Okay, so now let's see what do we have here. Okay, so now we have to prove congruence by taking the example of the sides and the angles. So how much we have done till now, like from the first lecture, I think you must have written all of that down. Revise that for 2 minutes, and then we will start from this new topic.
Wait, so what do you want me to do?
I want you to revise the essentials of congruency from the first lecture, everything about congruency, and the types of triangles also. Remember them also. Are you done?
Yeah.
So now if you look at this particular question in which they have given you an isosceles triangle. So, Jeff, what is an isosceles triangle in the first place? What is this type of triangle?
Isosceles.
Yes.
It's similarly equal.
Okay. And are all the sides equal? Are two sides equal? Or none of the sides equal? What is the relation in that?
Uh, three, all sides.
Okay, so for equilateral, you have the three sides of a triangle which are equal. For isosceles, you have two sides that are same or equal, and for a triangle which is known as a scalene triangle, you you have none of the sides equal. So for this particular question, because firstly we're going to identify how the triangle is isosceles, so it has two sides, just same. This third side is not similar to these two sides. That's why this is isosceles triangle. Okay.
Yeah.
Okay, so basically in this triangle what they have done, that they have drawn this perpendicular bisector. This is called as a bisector because it basically bisects and divides the triangle into two halves. And then after the bisector you have an angle, 90-degree angle, which forms after the bisector is formed. So there's one thing which is also a concept in this, that whenever you add another line in a triangle to divide that, you have the 90-degree angle just with it. It forms with it because this angle lies with the perpendicular bisector. And this bisector is perpendicular bisector because this bisector is bisecting the two sides, and here it is perpendicular to this side and to this side as well. So basically it forms two triangles like this. Okay,
Yeah.
so you have two triangles now. Firstly we have just one triangle ABC, but because we have this bisector and this bisector line is known as M, now we have the triangles ABM and ACM. These are two triangles. Now what they have said, that they are asking you to explain the lines, the sides which are equal. So they're saying that side AB is equal to which side? So side AB is equal or similar to the side AC because these two sides are equal. That's why the triangle is termed as isosceles triangle. Other than that, it cannot be named as any other triangle because only two sides are equal. That's why side AB is equal to side AC. Okay?
Yeah.
Okay, so now if we have to look at the angle, so basically, then if you have to understand this thing, that whenever they are saying that you have an angle or you have like for a triangle ACB, and they do this on the middle, you can say letter describes that this letter has an angle over it. It has an angle, and that angle should be equal to the other side's angle as well. Come on the board, and on the board I will explain this to you, that how this is done. You're on the board, right?
Yeah.
Okay, so for instance I have this triangle, and this is triangle ABC, and I have this triangle, and this is triangle DEF. So I have an angle here and an angle here. So now if I say that the angle at B is 90-degree, the angle at E is also 90. So that means that angle B is equal to angle E. Okay? Because
Yeah.
both of them
Yeah.
have the same angles. But they can also say that if we suppose this, then we can also say that angle A B C is equal to angle D E F. So what we are doing in this scenario, we are saying that the angle that is equal in all the scenarios is either these two angles, A and E. But the other angles or the other sides are just coming in conclusion. So that's how we manage the angles. And also, if you take another example here, if you take another example of a perpendicular bisector now, if you say X, Y, Z, and now it's M, and you have this angle right here. Okay, so now for this one, we obviously know that angle M is here, angle M is here, which is equal to 90-degree. But we also know that other than M, there's no angle of 90 degrees, so that's why it's not equal to anything. But these two triangles and the angles of these two triangles are equal. And how will we manage that? As we say that side XY is equal to side xz, and as we're saying that angle M is equal to 90 degree, so we can also say that XYM, sorry, XMY is equal to XMZ. And why am I pointing out at M? Because M is the common angle or common letter between both of them, and M is the only angle which contains similarity in both of these two triangles after being bisected by a perpendicular bisector. Okay?
Yeah.
Any confusion?
No.
Okay. So let's move then to our question again. Okay. So now they're saying that AMB angle is equal to which angle? So obviously AMB is equal to now AMC, and both of them have an angle of 90 degree. Okay, then they're saying that now AM is equal to which side, or AM is that into both triangles. So AM is a perpendicular bisector to both triangles because it bisects two triangles, it bisects one triangle and then forms two triangles of separate identity, but they are congruent as well.
Yeah.
Then they're saying that if triangle ABM means this triangle is congruent to triangle ACM. So yeah, that's right. Both the triangles, they are congruent. And why they're congruent, let's write that on the board because we don't have enough space here. Okay. So we're saying that one of the triangle, we had this triangle here, and M was the bisector A, B, and C, and with this angle, and these two were the similar lines. So obviously, if we have to separate them like this and like this, so you would say triangle ABM and triangle ACM, and both have the same angle, both have equal sides. That means that these two triangles, this triangle one is divided, it is broken up into two triangles by this bisector, and then both the triangles are congruent. Okay? Any
Yeah.
confusion till now? Are you having any confusions? Any questions?
No.
No? Okay. So I will just move on to the next question then. Okay, so the next question is quite interesting. So now they have given us from a triangle to a rectangle, and they're saying that this is a rectangle PQRS, and they're asking us to show that triangle PQR is congruent to triangle SRQ. So for this question, firstly we have to see the types of triangles and the angles. So if you look at this, they have said PQR. So PQR and SRQ. So SRQ. So basically, there's also a bisector, which was this line. This is a bisector again that forms the angles of 90 degrees on both sides, here and here, both on the both sides. And now if you look at them, if you make them like in individual aspects, now they would look like this. P Q R, and this is the angle, and then for SRQ, and this is the angle again. So if we look at this, we have the angles at Q and S divided. And then if you try to come on the board now, because there's not enough space here, I'll come on the board and write this question again here, because we have a rectangle here of PQRS, and the bisector basically came from here. So this was the bisector which bisected this whole rectangle into two triangles again, and we had, okay, so we had the angles, all the angles which are 90-degree angles and similarity. Okay, so this was the whole picture, and we said that we had two triangles, PQR and SRQ. PQR and SRQ. So for PQR, obviously it will be drawn like this. So then you would draw it almost like this if you are drawing it vertically. So it would be PQR and this angle, and we can also rotate it like this. Are you with me right now?
Yeah.
Okay, so after this one triangle, which is PQR, now you have to draw SRQ. So for SRQ, we will just draw it like this because it is easier than that one. So it would be like this, S, R, and Q. And this side is similar to this side. Okay, so for this particular question, what we have to do is that we have to manage the angles, we have to tell about the sides, and obviously how the triangles are congruent. We have to prove the congruency between them. So if this is our first triangle and this is our second triangle, first we have to see the sides. So we know that this side now, the side PRP, is equal to side SQ. So we'll just say that side RP is equal or congruent to side SQ. This is our first. Then you can also say that side QP equal to side SR. And then we could also mention that angle Q is equal to angle R, which is equal to 90 degree. Or we can also write this, that angle RQP is equal to angle SRP. Sorry, SRQ. So these three things, the sides, the angles, and the whole angle of the triangle, justifies this, that both these triangles, when they are formed from the rectangle, they are congruent triangles, and after they have been bisected by a perpendicular bisector, they are congruent triangles. So then we would write this, that triangle, hence this proof that triangle RQP is congruent, sorry, triangle to triangle SRQ. Okay.
Yeah.
Okay, so now I have done this question as well. Let's move to some another question. Okay, so we have proved this. I've proved this. Okay, so now we have another very interesting question. Now this is about the example or the diagram of a parallelogram. So Jennifer, do you know what like a parallelogram is?
It's like that shape, right? It's the shape.
Yes, the shape. Like rectangles,
Yeah.
triangles, it also a shape, but it is like it is a diagonal shape. You can say that it is a diagonal, and it forms many diagonal shapes. So they've now said that if you bisect a parallelogram, and we have a point P. So basically, they're saying that you're bisecting, then again, all of that. And then you have again two triangles. Basically, you have four triangles, but you're going to just cater two of them with the triangle EPF and triangle GPH. So these two triangles are not being discussed right now, but they can be, but they're not. Now they're saying that triangle EPF is congruent to triangle GPH, but how? So we have to prove that. Let's see, like, what is the congruency between them. Okay, so now we're going to draw this on the board. The example of a parallelogram. So it looks like this shape of a diagonal shape, and they've said we have EFGH, EFGH, and we have diagonals running through here, the bisectors, diagonal vertical bisectors, and this is the point P, where these bisectors meet, and then that's why we have these two triangles, which we'll talk about, and these two triangles. Triangle EF, oh sorry, triangle AFP and triangle GPH. So let's see what was similarity between them. Okay, the similarities are quite visible. This side will be this side and this side. So now if you look at this particular part, we have just two triangles, and because the angles are not so similar, they can be, but we can assume that the angles are similar, because if you draw them, then we would have P right here, and it would be EPF and GPH, and these sides are equal in both of them. So we can have this conclusion first, that side EF is equal to side GH, but we don't know what the other angles or sides are. So we can't vouch for this side or this side or this side. But obviously we can say that this P angle, because no matter what the angle is, the P angle and the P side, the P letter, the P part which is bisected in between is similar and is consistent with both the triangles and both the conditions. So we can assume that angle P is equal to, angle P is equal to any angle. Mostly it could be 30 degrees, or you can say 30 to 60-degree angle. It could be in between that, and it is similar in both the triangles, because both the triangles are bisected by a bisector, and P is the common point between both the triangles. So by just considering one part of this, like we have one side equal and one angle equal, so we can assume that both the triangles might be or might not be congruent, because that is basically a thought which we are working on. Now how the other sides are equal and not. Side EP can be equal to side HP, and side FP can be equal to side PG. And why is this? Because when they're bisected by a bisector, then they have been cut equally into an edge. And that's why when they have only one meeting point, when P is the common point, it is basically the common point, that means that the other two triangles have been bisected equally to each other. That means that that the side EP is equal to side HP,
Yeah.
and the side FP is equal to side PG. So that's why we can say that they have asked you to prove that. So we have proved that with size, proved that with triangles, and with examples. So we can say that now the triangles EF, sorry, EPF is equal to a congruent to triangle GPH. Clear?
Yep.
Okay, so now let's see what other questions do we have here. Okay, so a question about transformation and of angles as well. So let me just move a little upward and let's see that we have certain example transformation here, and then we will do them first. Jennifer, you know what a vortex is?
Huh?
Do you know what a vortex is? On the board, I'm writing the word. What is a vortex?
Wait. It's like it's a fundamental point in geometry where two or more line segments, rays, or edges meet. In polygons such as triangles and quadrilaterals, a vertex is where the side connects, forming corners. For example, a triangle has three vertices, one at each corner, while a rectangle has four vertices.
Okay, so let's see how the vertices are formed and how we can name them in triangles, rectangles, and other diagrams. So if we have a triangle, so if it has three vertices, it has three vertices. And why does it have three vertices? Because it is combined at three sides. It has 3 points, which are, you can say, rigid points. These 3 points, which are not movable, they're not movable points. They're the points where these two lines, this line is met with this line, this met with this, and this met with this. So when the points meet together, the lines attached together, then you say that those points are called as vertices, and one point is called as a vertex. So tell me, how many vertices are in a rectangle and how? Jeff, how many vertices are in a triangle?
One, two, three, four.
Okay, so the triangle we have three and the rectangle we have four. What about a circle?
Zero.
Zero. Good. What about a parallelogram?
Four.
Four. Okay. So now we will do the questions again because we know what the vertex is and we've cleared about that. So I'm going to just come again on this screen. And we had some questions which we had to do for transformation. We will do that them as well. But
No,
let
no,
me
my dad
see.
is doing it.
What?
Nothing.
Okay. Let me see which are the ones which we missed. Okay. So, Jennifer, this one question we have in which we have to reflect this triangle. So, how do you think we have to reflect this triangle? Because we learn about the types of transformations. Any idea?
No, no.
Okay, let's do that. So, for reflection, I have told you that in reflection, you have to basically reflect the image oppositely.
Yeah, no, I do know. Yeah, no, I do.
Okay, so for instance, if we have this image, then this is the reflection of it. If we have this image, then its reflection is this. So basically, they are the mirror images of each other. So if we have this image now, and they are firstly asked us to reflect that in x-axis and in y-axis. So what we're going to do, firstly, you have to look into the types and the numbers. So it is 1, 2, 3, 4, and 5. And this is the first quadrant, this is the second one, this is the third one, and this is the fourth one. So basically your triangle is now in the negative axis because it is the second quadrant. So now we have to reflect that into the x-axis and into the y-axis as well. So what we will do here is first reflect that here with the same numbers. So it lies in the gap of 1, 2, 3, and here it lies at 1, 2, 3, 4. So if you have to write the quadrants of it, you will write 3 and 4, 3 for x-axis and 4 for y-axis. And this changes in every quadrant by numbers, by either positive or negative changes. So we have to reflect that in the next axis. We would do it like this: 1, 2, 3, and 1, 2, 3, 4. So you draw it like this, then like this. From this point, 1, 2. So this right here is the reflected image, and because now we have both the positive axes, it's 3, 4, and here it was minus 3, 4. Okay?
Yeah.
Okay, so now if we have to reflect this into now this quadrant, the fourth one, we will do the same thing: 1, 2, 3, 4, and 1, 2, 3. So we'll do it like this. So now the quadrants we have are plus 3 and minus 4, because we have 4 in the negative y-axis and 3 in the positive x-axis.
Yep.
And this one, if it replicates in the third triangle, it would be like this. So again, we have to pick, like, obviously 3 from here and 4 from here. So it would be like this. Like this. Okay?
Yeah.
So in what these 4 quadrants we have done, we have reflected the image in different ways in all the 4 quadrants by keeping the coordinates same. So you have to identify what the coordinates are in both the triangles, sorry, in the triangle, and you have to identify the parts in the x-axis and in the y-axis. So if I look at another question like this, let's see if we have another question like this one. We did this one. Have to do another question like this. Okay, so Jaref, you have to tell me that in this particular question, question number 7, they have asked us to say the vertex coordinates of ABCD. So how can we identify this?
Well, like, are you saying there's 4 vertices in ABCD?
Yes, there are, but they're also saying that say the coordinates. So we have to identify them from the graph. So we have to make the first. We have to make the graph. We basically have 1, 2, 3, and 4 points here, and again 1, 2, 3, and 4 points here. So now if we try to manage it like this, we know that the points A and B are at, B is at point 1 and 1. Okay, A is at point 4 and 1. C is at point 1 and 3, and D is at point 4 and 3. Got it?
Yes.
Okay, so why have I done that? If you look at this triangle, you have to identify the coordinates. You have to identify that which part, which element, or which number lies in which coordinate. As B part of the rectangle, sorry, is present in, obviously, this axis is the fourth quadrant, and here it has positive x-axis, sorry, negative x-axis, and positive and a negative y-axis. So you have to do it like this. Now we're doing the negative and positive sides as well, because we have both negative axes. So here B is present at this point 1 and 1. A is present at this point 4 and 1. C is present at 1 and 3. And D at 4 and 3. So this is how a rectangle is made in a in the coordinate plane, and how the coordinates are being placed at as vertices in a triangle. Okay?
Yeah.
So now they're saying we have to rotate the triangle about 270 degrees. So we have to understand what they're saying by 270 degrees. So let's look at the board and understand what they're like meaning by that. Okay. So if we have a circle, we have obviously four parts, and they're starting from 90, then 180, then 270, and then 360. So basically, if I say that rotate like this is like rotate by 90 degrees. Like this, half circle, that is 180. This, then it is 3/4 of a circle, then it is 270, and complete circle, that means 360-degree roundabout. So if they're saying rotated by this angle and rotated clockwise, that means I have to, this is basically clock rotates like this. If we just look at the clock, okay, so it moves like this is clockwise and this is anti-clockwise, so we have to rotate it like this, like this, the, you can say, more than half of a circle in to 70-degree angle in clockwise direction. This is anti-clockwise because you are moving against it, and so clockwise. So if you now write that on the board, when they're saying that rotate it to 270 degrees about O and state the vertex coordinates of the image. Okay, so now I'm going to erase this. So basically O is the point here which is known as the origin. That means we have to rotate that on this side. So if we do that, by rotating it, we would have this basically category. Let me erase it. And the sides would be opposite. It would be now D, C, A, B. And now the coordinates would also be different. And now if you look at the coordinates, it would be for D, it would be 1, 1. For D, it would be 1 minus 1. For C, it would be 4 and 1. So 4 and minus 1. For A, it would be 1, 2, 3, 3 and 1. So it would be 3, 1 and minus 3, and for B it would be 4 and minus 3. So basically now the whole coordinates are changed after rotation. So we could write this down that the coordinates change after rotation. Okay? Because when you're rotating it, you're basically doing a very opposite thing. You're rotating it in a very opposite manner. You rotate something, it becomes opposite of what it was. So the same thing happened that for this particular example or diagram, we have the vertices became opposite because the diagram is now opposite of what it was. So now we have uh, done this part, we have done this part and this part as well. Okay, let's see what we have next. Okay, so I think we did this one. This is left. Okay, then we have this one and this question as well. Let's see how many questions do we have left other than that. We did this one as well, and yes, we have done majority of our questions. So I'm just going to give you a task which you have to complete. I'm writing that down on the board. Your task for next week. Do you have time to do that?
Yeah.
Okay, great. Task for next week. Okay, so when should I share the PDF with you because then you have questions with you and you can practice the questions. Are you hearing me? Are you is my voice
Yeah.
audible?
Yeah.
So this PDF which I have of questions for you, I'm going to send this PDF to you as well so that you can practice questions which are present here. Okay?
Yep.
Okay then. So I guess we have completed, I think, a lot of the chapter. And the next lecture would probably be the last of this chapter, because the chapter was very long. It obviously had many different concepts as well. So in the next lecture, we will learn about the remaining questions. We will solve them, and then we will do a test, like, and then you will give me. I will give you homework, and you will do the questions on your own. So for transformation as well, it is difficult for some, like for some concepts, but congruency is easier than transformation because congruency doesn't have such complicated things. Transformation has, because you have to change the diagrams by by, you can say, translation, dilation, and rotation, etc. So all of them are a little tricky, but obviously you'll clear all of them in the next year as well. So we have 4 minutes left. Do you want to ask me something? No. How is your school?
Good. Good.
Good. What activities are you doing nowadays? Because it is very cold.
School hasn't started. It starts tomorrow.
Okay, it starts tomorrow. So like, are you excited because you are going to meet new friends, or you're like we have to go to school and just be like spending
Now
time?
I'm excited.
Excited. Okay, so
Yeah.
what games do you play? Like, do you play any games on your laptop or computer?
I'll watch YouTube.
So you don't play any games? I'm just shocked because I've listened to like people make playing Fortnite and Minecraft and I don't know all of that takes, but I'm shocked that you aren't playing any of that.
No.
Okay. Okay, so like you just like you just, do you that jam on YouTube? You don't look at any other thing? Any other thing? No? Okay, so that's a good thing. I think your parents must be very proud that you're not using any games and you're investing your time in studies. I think yeah, that's good.